In this video, I'm going to talk about the power rule for derivatives, okay? So my function is f of x is equal to x to the power n. In the first scenario, I'm going to assume that my n is an integer, okay? Positive integer. So n is an element of 1, 2, 3, dot, 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 okay? Then we will extend this idea to any real number. So we want to find out the derivative of this function. So that means f prime of x. That's what we are looking for. By definition, it is limit h approaches 0, f of x plus h minus f of x, all of it divided by h, which, by the way, is going to give me limit h approaches 0. So my f of x is equal to x to the power n. So f of x plus h is going to be x plus h to the power n minus f of x, x to the power n divided by h. We just need to find this limit. To find this limit, we need to expand this x plus h to the power n by using something called binomial theorem. So binomial theorem, what it tells you is this: x plus h raised to the power n, where n is a positive integer, is going to be equal to x to the power n plus n times x to the power n minus 1 times h plus n times n minus 1 divided by 2 times x to the power n minus 2 times h square plus dot 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 plus n times x times h to the power n minus 1, and the last term is going to be just h to the power n. We are going to use this formula to find the limit. However, I kind of want to touch on these coefficients of x and h. So these coefficients are nothing but combination. So this is written as NCK. So that means combination of k items from n distinct items. In this case, combination of n k numbers from n numbers 1 through n. Now, this is also written sometimes as NK. And the formula for this is nothing but n factorial divided by n minus k factorial times k factorial. What is n factorial? N factorial is the product of first n positive integers, so 1 through n. So for instance, 4 factorial is going to be 4 times 3 times 2 times 1, which is, by the way, 24. So this is just as a side note. I don't expect you to be memorizing this or anything, just as a side note of where it comes from. If you want to explore further on this, you can go ahead and just type in binomial formula on Google and you'll find lots of information. But anyway, so let's continue with this and plug in this into this limit. If I do so, I get the following. So upon plugging this into this, I get this. So just straightforward, inside the square bracket in this formula, and then there is a negative x to the power n and there is a positive x to the power n. So they are going to cancel each other out, leaving me behind with this, all the terms from here to up to here. Now, in the next step, what I'm going to do, I'm going to factor out an h. Do you see all of them have h in it? I could factor out one h. That's going to give me, in the first term, n x to the power n minus 1. So you may want to pay special attention to this term, n x to the power n minus 1 plus n times n minus 1 divided by 2 x to the power n minus 2 times h, and keep factoring out h from each of this term, and the last term you had h to the power n. Now it will be h to the power n minus 1. Now this h in the denominator and this h in the numerator are going to cancel out. Then you'll be left with whatever is right here within the square bracket right here. Now this is a limit of sum, which is the same as sum of limits. But we notice that all of these terms, except for the first one, has h in it. So as h approaches 0, all of these term are gonna approach 0. And in the limiting case, that value is gonna be exactly equal to 0, leaving me behind with nothing but this. So I get n x to the power n minus 1. So my derivative of f of x equal to x to the power n is nothing but n times x to the power n minus 1. So we just derived that derivative of x to the power n is equal to n times x to the power n minus 1. So this is a formula. Now this idea, by the way, can be extended. So far we have shown it for positive integers. It could be extended to any real number. So for any real number, if you have f of x is equal to x to the power n, then f prime of x is going to be equal to n times x to the power n minus 1. And this is a formula you may want to remember. Now, I'm not showing you the proof of the case where this n could be any real number. So n is a real number. N is a real number. The real number case, I'm not showing it to you, but for the integer part, which is easier to show, I have shown it to you, and we will assume that this idea can be extended to any real number. I hope that this discussion was helpful. Thank you very much.